Hi there, my name is Taha Tubaili from the Knowledge Media Institute, the Open University UK. Thank you for attending my talk about my paper, Lexical Induction of Morphological and Orthographic Forms for the Low-Resource Languages. I'll brief about the motivation, background and challenges, the approach, evaluation, and contributions. First of all, we define the lexical sparsity as the size of the vocabulary in a given language. And this is composed of mainly two things, the morphology and the orthography of the language. Unlike the simple morphology of English, in Arabic there's the inflectional and derivational morphology, such that one word could be inflected up to 100, 200, or even 300 words. Or one word could be derived into several other words of different meanings, such that play could derive toy, messing around, field, player. Write could derive writer, scripture, book, books, office, library. The other factor is the orthography, and this is significant in spoken languages that lack a standard orthography, such as Swiss German, Alsatian, Javanese dialects, or Dialectal Arabic, such that one word could be written in several different variants, and this immediately becomes challenging for word classification tasks. The intuition to sort this challenge out is to do text normalization and then stem the word or limitize the words, such that several different variants could be mapped with one word. Enjoying, enjoyed, enjoyable could easily be mapped with the lexeme enjoy. However, for Arabic, we have prefixes, infixes, suffixes, and diacritics that it becomes difficult to extract the stem of the word. Denying, for example, the word istinkar could easily be mapped with 11 words of different meanings. Our proposal is to induce words with their inflectional and orthographic variants from a corpus automatically. We do that using a rule-based approach mixed with word embeddings. Our case example is Arabizi, which is a portmanteau for Arabi and Inglesi, meaning English. It's a transcription of the spoken dialectal Arabic and Latin script using numbers and symbols, such as this word, habibi. Right, so there are several variants of Arabic. There's the modern standard Arabic, which is the formal Arabic. It is understood across all Arab regions. However, when Arabs speak, they speak their dialectal mother tongue, which is very different from the modern standard Arabic. It is also different across regions, and it's purely spoken. As such, when people text in Arabizi, they are reflecting their dialectal Arabic, but in Latin script. And this is all started when there were keyboards lacking Arabic script. We looked at the literature. We found that most of the resources, they are for the modern standard Arabic, and researchers, they either completely discard the Arabizi, they filter out from their data, or they try to transliterate it back to Arabic, but this is also challenging, and it is a bit irrelevant in our case. The orthography challenge or issue in Arabizi is that one word could be mapped or written in several different variants. And this is because people transcribe as they pronounce. If one person pronounce a word different from another person, we're going to have two different transcriptions. There's inconsistent orthography for the vowel phonemes, such that each person, they transcribe the vowel phonemes according to their own perception. And there's little consistency because people had made some consonant letters standards. And these are the ones distinct in the Arabic language from the Latin script languages, such as the ha, kha, ayn, ghain, and the glottal stop. These are the guttural phonemes. The kha is written as a compound kh or 5 or even a number and a symbol. As such, the sparsity of the language becomes each word multiplied by the morphological and orthographic forms of that word, which becomes very large in this case. We use existing resources from our previous work, We have a sentiment lexicon of 2,000 words. We have a data set that is annotated as positive or negative. It is 1,600 tweets. We also have a corpus of raw Arabizi data composed of 1 million public comments. What we've done previously is that we've expanded this lexicon of 2,000 words into 24,000 words using word embeddings, just the classical cosine similarity nearest neighbors. Now, we propose several steps to further expand the first original lexicon. First step is the text normalization. We convert all compound letters to a single symbol that represent the phoneme. For example, over here we have sh or ch. They both represent the letter sh in Arabic. As such, we designate the symbol dollar for this one and for the rest of the compound letters. We have a rule-based matching, and this is the essence of the research, is that we take the consonant letter sequence, meaning we omit all the vowels to have a sequence of consonant letters, such as this word, sahtan, which means cheese. And then we permit some possible prefixes and possible suffixes that we only observed. We allow this for words that contain a CLS of size 3 or above, and we match it with all the words from the Facebook corpus. Now we are manually matching all the words. Previously, we were using just the word embeddings to look for similar words. However, we also add the word embeddings, but for a different reason than before. Not for expansion, but for scoring the words, and this will help us also disambiguate the words. By scoring the words, every matched word is going to have a score between 1 and 0. Most similar words will take a score of 1, and least similar will take a score of 0, and then we sort them out. We also associate these scores, the similarity scores, with the words as sentiment scores. So this could potentially also improve the sentiment analysis for the evaluation later on. Right, so how do we use these scores to disambiguate the words? As I mentioned earlier, the lexicon is composed of a positive and negative sublexicons or sentiment lists. But what if we have a word in the positive list and a word in the negative list that share the same CLS, such as this word below? Then we can easily eliminate the word that has a lower score, because a copy of this word exists in the other list with a higher relevancy to the original lexicon word. This approach surprised us because some words they matched with around 1,000 or even more words, such as the word ihtiram, which means respect. And this also consolidates the theory that lexical sparsity could increase so much in size for languages of non-standard orthography. And this is a major challenge as well. Finally, the final step of the approach is something that we wish that we could have avoided in a way or another, is the manual filtering. We learned that many words matched with completely irrelevant words. And after investigating, we realized that those words, they contain a CLS of a very common words, and this was the reason for this irrelevant matching. Ideally, in a better case, we would have trained contextualized word embeddings to give us the relevancy scores of words based on their context. And this would have hypothetically improved the word scoring, that we could automatically eliminate the irrelevant words. But given the low resource, 1 million comments was so insufficient to train a new language model capable of understanding the contextual similarity. As such, one native student eliminated the words that were irrelevant, meaning if a word mapped with lots of irrelevant words, they would only look at these matches and they would say whether this is a good expansion, good induction, or a bad induction. This approach induced 171,000 words from a lexicon of 2,000 words, which is composed of 70K positive and 100K negative. We name it Sensi large. For the evaluation, we apply the same evaluation over the previous versions, and we compare the results. We do a lexicon-based sentiment classification, which is very simple. We check every word if it exists in the lexicon and give it the associated score, and then aggregate these scores at the end to classify the word as positive or negative. Our data set is composed of 800 positive and 800 negative tweets. This is, of course, an extrinsic evaluation just to see how the induction is doing. Right, so in the evaluation, we have two steps. First, we look at whether the tweet was classified, yes or no, and only if classified, we look at the result of the sentiment analysis. We can tell from the original lexicon that it only classified 22% of the dataset, and in the new Sensi large, the one we just developed, classified 68%. However, the recall dropped a bit and the F1 score, and we assume this because of the very large induction. There were many irrelevant words introduced. However, we are going to check this now using the error analysis we present. We took a sample of 100 tweets from the dataset, of which 24 tweets were wrongly classified and 12 were unclassified out of 30 unclassified tweets. We manually found that there were 30 sentiment words from a vocabulary of 178 words, where the sentiment lexicon missed 24 and falsely classified 19 words that are non-sentiment words. The main type of errors were the word is either an orthographic variant that does not exist in the lexicon, and this shows that although we had a very large induction, yet the sparsity is so large that it is still not encompassed in a single induction or in this lexicon. The other issue is code switching, which is a whole direction in research that we did not address, is when people, as they text the Arabizi, they use an English or French sentiment word. Third is the false neighbor. If we have a positive or negative word in the lexicon, but then the matched word was a word that is neutral. Such as this example, معلم, which means expert, it matched with معلومة, which means a piece of information. The other errors were multi-word expressions, contextual and polysemic words, sarcasm, tweets without sentiment words, which are basically known issues or challenges in the lexicon-based sentiment analysis approach. This is the table to present the distribution of the error. As you can see, the most of the error was in the orthographic variants, code switched words, and the false neighbors. In any case, we have a new approach for lexical induction. It was a mix of rule-based with word embeddings. It is cheap. It works with small corpus. The only limitation was the manual filtering of the irrelevant words. However, for the future, in a better situation, we would definitely try to collect more data and use contextual word embeddings. We also plan to apply this on different Arabic dialects and different Latinized languages such as the Hinglish, Finglish, Greeklish. We also presented a new Arabizi sentiment lexicon composed of 170K words. Thank you so much for listening, and for reference, we have a web page with all the resources on it.